So now we start understanding how we can actually use pointers in a useful way. Recall that I said there were three things that pointers were good for, and the first is to do with function parameters. So let's look at that. Recall that I said one of the main reasons pointers were invented was to allow programmers to design functions that could modify their parameters. Recall the double-it example. The little double-it function doubled the parameter that was passed into it, but out in the main, after you call double-it, if you do a printf of that value, it was not doubled. In other words, the double-it function did not actually double its parameter at all. Well, it doubled its parameter, but as soon as the double-it function disappeared, the copy of the parameter disappeared with it. The original, out in main, was never doubled at all in the first place. So how do pointers help us with that? Okay, and here's how. A function cannot modify a parameter. It can't ever modify a parameter. Well, it can, but only if the parameter is an array, like a string or something. So, except for arrays. We won't talk about arrays. In fact, arrays have got something to do with pointers, which we'll see later anyway. The bottom line is, I guess that you could call it a golden rule. A function simply can't modify a parameter. It can't ever modify a parameter. And that using pointers doesn't change that. If you pass in a pointer, it can't change the pointer. But if the parameter is a pointer, the function can modify the thing that the pointer points to by simply using the asterisk operator. Remember that? The asterisk operator? The thing that the pointer points to, you can change that. You can't change the pointer, but you can change that. So, instead of passing in an integer, using the integer as an example, instead of passing in an integer, you pass in the address of the integer. The function receives its parameter as the address of an integer, or in other words, a pointer to an integer, and then that function can then change the original integer by simply saying whatever this pointer points to. I'm going to show you an example of that, a proper worked example, so if that sounds confusing, don't worry. So just recall that I said that instead of passing in the integer, you pass in the address of the integer. Now hopefully that will make it clear why scanf requires us to put an ampersand on the front of all parameters. Well, all parameters that aren't strings anyway. Why? Well, because remember, if we want scanf to actually change the parameter. If we're saying to scanf, please read us in a number, let's say an integer, we're doing a %d, a scanf of %d, then one of the parameters to scanf, the second parameter in fact, is the actual integer that we want it to fill in for us. We pass it in an integer and we say fill in this integer. But also I recall that I said a function can't modify a parameter, so scanf cannot modify that integer. It simply can't. It can read a number in from the keyboard, but it cannot put that number into the parameter that we passed it. So we don't pass it in the integer directly, we pass it in the address of the integer and say here is the address of the piece of memory where I want you to put the integer that you read from the keyboard. Scanf assumes that that's a valid piece of memory, reads an integer in from the keyboard, puts it at that memory address. In other words, it goes to that memory address and writes to that. It never actually changes the memory address itself, because functions cannot change their parameters, and the parameter is the address. It doesn't change the address, but it does change the thing that the address is pointing to. Then when scanf's finished, we can go and look at that memory address and find, well, the integer has been filled in. Isn't that magical? Okay, let's go and look at an example of that. I'm going to go back to the double-it example. Okay, so here's double.c. This is the double-it example that I was talking about. This is, I can't remember what chapter this came from, but this is the piece of code that simply attempts to double the parameter that you pass in. Okay, so just to refresh your memory, down here in main, we've got a number, an integer declared, then we read that in from the keyboard, then we pass it to the double-it function, which is attempting to double it. So it just says n1 equals n1 times 2, and it does that to this n1 right here. So it doubles its own parameter, and then we come back out here and we attempt to print that out. So let's see if that works first. compiles, please enter the number 23. The doubled value is 23. Now that's clearly wrong. It's not doubling the number at all. And if you recall, it's not doubling it because this n1 over here is a duplicate of num1. It's not the original, it's the duplicate. So the duplicate is getting doubled, but the original num1 is, well, nothing's ever happening to it. It's never being touched. So I'm now going to modify this program such that we can enable double it to do the work that we want it to do. We're actually going to get double it to modify the parameter that gets passed in. Well, obviously we're not going to get it to modify the actual parameter because functions can never modify their parameters, but if we pass in a pointer, we can get double it to modify the thing that the pointer points to. Okay, so here's how it's going to work. Instead of passing in the number, the integer itself, we're going to pass in the address of the integer. Okay, so that's the first step. Now, that means that as it stands, the program will not compile because here we're passing it the address of an integer, whereas here we are simply receiving it as an integer. Now we don't want to receive it as an integer, we want to receive the address of an integer. In other words, we want to receive a pointer to an integer. So we now declare that n1 is a pointer. It's a pointer to an integer, or put another way, it is the address of an integer, which is good because we're passing it the address of an integer. Okay, so now this line of code here clearly needs some modification because what we're trying to do is we're trying to say n1 equals n1 times 2. At the moment that's not correct because n1 is a pointer, in other words it's an address. So if I was to say n1 times 2, I'm actually doubling an address. Now that's obviously ludicrous and totally meaningless. What could it possibly mean to double an address? In actual fact, I don't want to double the address, I want to double the thing that the address points to. In other words, I want to double the value that the pointer points to. So in other words, I want to do this. I want to do star n1, in other words, the thing that n1 points to, multiply that by 2, and put that back in star n1. You see what I'm doing here? If you're not sure exactly what's going on here, then just recall back, go and have a look at the notes again, maybe rewind the discussion on understanding basic pointers. What I'm doing here is I'm saying the thing that pointer, well, maybe it would help if I actually renamed this PTR. Okay, so now this is a pointer to an integer. Hope that's clear. This says the thing that the pointer points to, double it. Now what does pointer point to? Well, it actually points to this. Because what's going on here is when you call this function and you pass it this value, there's a little implicit assignment statement happening. Somewhere in the middle, it's never actually typed anywhere, but something that's happening in the middle of all this is ptr equals the address of num1. The num1 is obviously this num1 down here, and the ptr is this ptr up here. So when you call the function, you're actually assigning that value to that variable. Does that make sense? So when we come to this line and we say the thing that the pointer points to, which is num1, multiply that by 2. So the original here, this num1, is getting multiplied by 2. And then we put whatever result we come up with, we put that back into star ptr. In other words, we put it back into num1. So what's actually happening is that this is happening. That's what's really going on behind the scenes. Okay, I'll just remove those extra lines of code because we don't need them. It's really vital that you understand this. This is done just everywhere in C. Double it receives as its only parameter the address of an integer. And then it goes to that address, finds out what's in there, multiplies that by 2 and puts it back at that address. That's all double it does. And we are going to pass it the address of the integer that we're involved with, this one. So let's see if that in fact does what we need it to do and doubles the value of the integer. Compile, no errors. and run. Enter the number 23. The double value is 46. Okay, so that is working. So we now have effectively a function that can modify its parameter. It's not exactly modifying its parameter. It's modifying, well, it can't modify the parameter directly because the parameter directly is an address. You can't modify the address, but you can modify the thing that the address is pointing to here. Okay. So that's what I meant when I said functions can now modify their parameters. If you want a function, this is the golden rule. You can remember this if you like. If you ever want a function to modify its parameter, then you can't pass in that parameter, pass in the address of that parameter.